Welcome everybody for our last and final showcase. This is the Launchpad Showcase, and we have three amazing companies here to tell their story quickly in about 5 minutes and then take some questions. We have Terra Quantum, which we'll present first. Then we have BosonQ Psi and qBraid third. So you guys are going to just hand it over to the next one.
Yes, that sounds
And if
perfect,
you have
yeah.
any questions, let me know. But thank you for being here this afternoon. Go
Yes,
ahead.
thank you very much for having us. Thank you guys for joining. So I wanted to introduce Terra Quantum. We are a European quantum technology company focusing in 3 different domains. First domain is algorithms. We develop hybrid quantum algorithms across 3 areas: optimization, quantum machine learning, and simulation. I'll go into each of the areas in a bit more detail in a second. We also have a joint venture called qMware in Austria, where we build a hybrid quantum cloud, so combining the best of classical with the existing quantum computing companies. And then the third pillar we focus in is security, where we are focusing on post-quantum cryptography, PQC, as well as QKD. We spread globally. We have our headquarters in Munich as well as St. Gallen in Switzerland, but also larger presence here in San Francisco in the Bay Area. But Kim, my colleague, is from from Washington, so even a local one. And we kind of have roughly 200 employees with 150 quantum physicists researching across these domains. So a very large quantum R&D team with a big IP portfolio that we've developed through customer projects. So we're very application focused. We don't build our own quantum hardware. We focus purely on the software, and have been working across industry with companies from Thales in the defense space, POSCO in steel manufacturing, Evonik in chemicals, and so on, right? So, yeah, very much industry agnostic. And the way we approach our algorithms as the first kind of pillar, we develop hybrid quantum algorithms. For most of you in this scene, it's already a term. So we kind of combine the best of the existing classical CPU and GPU, partnering with NVIDIA here, with the existing native quantum computers. So we are very agnostic to the backend that we're using, from IBM to Quicks and so on, right? And kind of try to drive the performance advantage through optimization, machine learning, and simulation. And we developed libraries for each of these areas. TQOpt is our optimization library, which basically looks at hybrid quantum optimization for combinatorial optimization problems like logistic routes optimization and so on. TQML is our quantum machine learning library, focusing on time series prediction as well as other quantum machine learning things, and we've built a rich portfolio of IP there, like hybrid quantum neural nets and so on. And TetraBox is our simulation library, where we look at black box optimization, Monte Carlo simulation, the finance industry, and so on. And all of these libraries are packaged into our TQ42 cloud, which basically makes our algorithms accessible via an SDK that can be integrated into the client's suite. On the back end, we kind of leverage the best of the available resources like Google Cloud, IonQ, and so on, right? So very much flexible backend. But that was the algorithm side. We also focus on security, the second big pillar of our business, where we kind of built applications like quantum secure communication messaging service, a deepfake protection and detection service, as well as some solutions on the quantum blockchain. But our key product here is the PQC, the TQ42 cryptography library, which were just validated by the NIST on our open source library. So it's also validated by the program and readily accessible, which is very interesting for a lot of clients such as the US Air Force, whom we're working for with PQC. We just won a research grant with them, trying to build a quantum secure communication line. And yeah, basically a little bit more detail about our TQ42 cryptography library, involving all the 3 FIPS standards that have been recently released, making them readily accessible, and very interested in partnering with companies and bringing these standards to life. And as already mentioned, we are very much industry agnostic in the solutions that we deliver. For example, in the finance industry, we've been working with HSBC on improving collateral portfolio optimization, as well as faster options pricing. Got very interesting results through our enhanced Monte Carlo simulation solution based on tensor networks. With Uniper, it's an energy company from Germany. We've been optimizing the LNG shipping routes based on a multi-constraint problem, and kind of gained a 5 to 10% EBITDA improvement for the client, so a very significant business case behind it as well. For POSCO, it's a Korean steel manufacturing company. We were optimizing their blast furnace through multiple different models and sensor data based on our quantum machine learning solution for the time series prediction. And that was also a very significant result and cost reduction for this company. So as you can see, very much industry agnostic, trying to find the right use cases, making quantum useful today through this hybrid approach. And while implementing this hybrid, we kind of bridge the gap of development of the actual hardware and hoping to upgrade once the hardware is more mature and get better performance results as well. So yeah, that's us in a nutshell. And I'll probably hand over to you guys over there. If you have any questions, please let me know. Happy to answer. Thank you.
Hello everyone. Myself, Abhishek Chopra. I'm the founder and CEO of BQP. Excited to be here. And I'm going to talk a little bit about BQP and what we are doing in the space of engineering simulations. Quick overview first for the company. The company was founded by 3 founders, 2 engineers and one computational finance person. We are not quantum physicists like every other company. We are looking into the specific area, a niche of market, I would say, in engineering simulations. A quick background story about myself. I'm an aerospace engineer and a computational scientist by trade. I've developed large-scale simulation codes which ran on massive supercomputers, first on CPUs. There is where I was running these simulations, which actually took 6 months with 250,000 computers running parallelly. This was a simulation understanding the turbulence behind an aircraft. And what I got from it is that this is a critical tool, but it is something that needs to become more democratized. One of the ways to solve that was by looking into working with Oak Ridge National Lab and NVIDIA to bring these simulations from CPUs to GPUs. And what I found out was that even though we have the computing power available, the algorithms or the back end of these simulations are outdated since 1980s. They've actually not changed. So started BQP with my friends here. One of my co-founders is right there behind. And what we are essentially doing is this world of simulations. So just to give a background, all heavy industries use simulations for design and testing purposes. And what is common between them is that they're fighting the status quo, that you can only do so much with current tools that are available today. So what goes behind these is complex mathematics and computing power. These are the 2 very critical components of it, and there's a mismatch between them. Since 1984, when the first codes were written in this area, the power has gone, the computing power has gone tremendous up. We know Moore's law and whatever the definition you want to put there, but the back-end algorithms have literally remained the same in the past 40 years. And this is what the mismatch creates the engineers to always choose between simulations which are faster but not accurate, or you have accurate simulations which are slow and expensive. And we are trying to solve this issue by bringing the back-end technology forward by 40 years. And the way BQP is doing that is using our next-gen simulation platform. So the platform essentially is something which is at an application layer. So it sits on top of the middleware and the quantum hardware, or you can say CPUs and GPUs for that matter. And one of our first ones that we're commercializing in the space of engineering simulations is the engineering optimization solver, which is essentially utilizing our quantum-inspired algorithms to solve complex optimization problems such as design problems, problems in engineering for aerospace and defense companies particularly. We are also working on partial differential equation, or you can say physics-based simulation solvers, and then data-driven simulation solvers. The whole platform is seamlessly integrable into existing workflows. So whatever currently engineers use is what they will be continuing to use. The input remains the same, the output remains the same, and even the infrastructure for that matter remains the same. It's just that they can go home sooner or take shorter coffee breaks. So, and we are not only doing things today, but we are also gearing up for the future. We are also getting ready when quantum computers will be here. Here's one example that we did with one of our aerospace customers on design problem. The goal here was to reduce the weight of the wing section, and because wing section is tied to the fuel cost. What we were able to showcase, this is by the way a multi-objective, multi-constraint problem, highly nonlinear optimization problem that is very tough to solve with your current state-of-the-art solvers. So we were able to reduce the weight by 6%, but also did that at 1/10 of the time in doing so. So what BQP does for companies, it helps to accelerate the product cycles much faster. It brings products which are more robust sooner out in the market so that they can start commercializing on those products. And that's what we are doing particularly for aerospace defense companies. I think I'm out of time, so I can go, okay. So I might not be able to show all slides, but I have one slide that I've really focused on. All this is great traction and everything, but this is a recent breakthrough that BQP has made, and this is live on archive right now, which is basically a jet engine simulation, which was previously from Gordon Bell Award. It took 19.2 million computers to do this simulation. And what we were showcased that we did a scalability study from 4 qubit all the way to 11 qubit, and that from a resource estimation point of view estimated that with 30 logical qubit quantum computer and with 4,000 gate, we can actually simulate the same problem. So imagine a world 5 years from now, or maybe 2 years from now, because I've seen some roadmaps published today, that we have 50 qubits going to be available soon. What it means really is that what would engineers access to 2 or 5 years from now? 19.2 million cores or 30 logical qubit quantum computers? I bet on the later. I should you too. So thank you so much for the presentation, and happy to answer any questions if there's any.
Hello, everyone. So last but not least, we're almost there, and then we can grab dinner and drinks, which is all that we're here for. All right. But what we're really here for in Washington, D.C., is to really think about some of the infrastructure we're building for quantum competencies in quantum computing, as well as quantum information science and technology. In this fold of many countries building up workforce development, building up research facilities, supercomputing centers, you've got to think, okay, you just bought yourself a $20 million, $40 million quantum computer. Where are you going to have people access it? Are you going to even have an interface for people to be able to do their research? What are you going to do to teach people how to use this facility as well as the hardware you've provided? Now, qBraid does a lot of things, as I'm sure a lot of other quantum computing companies do. But I wanted to today just focus on the research as well as the workforce development and how our platform enables that. So if you're going back to your legislator, if you're going back to an investor or some people who are working on the supercomputing side, you can put qBraid into your local development and deploy it to have the best interface for your quantum computing, AI, and GPU, CPU, QPU needs. All right. So first and foremost, we have over 20 plus devices available on qBraid. That's not just through your Amazon Broadcast Azure. This is actually all includes some exclusive devices that we have through partnerships with various quantum computing companies. And in fact, we have some really exciting white labeled products that you'll see across various other quantum computing companies where they're using qBraid for learning, building, or deploying their solutions. How we like to do this is we take people in 4 steps. You learn with the qBook platform. This is a White House Q12 initiative endorsed product that can be white labeled as well. In fact, you can also deploy blogs and deploy products there. qBraid Lab, this in fact has been officially endorsed by IBM. Jay Gambetta himself was like, DMing people and just use qBraid Lab because they got rid of their IBM Quantum Lab. In fact, it's been used at Quantum Qiskit Global Summer School, as well as many others. The qBraid SDK allows you to then take all that you've learned from lab and then start deploying this with various frameworks from Circ, Qiskit, PyQuil, PennyLane, you name it, Chasm3, QIR. Those are all available to access a backend through qBraid SDK. When you're accessing a backend, it's not as trivial as just saying, oh, I'm just going to run a virtual circuit. You still have to think about your optimizations. You still have to think about your orchestrations with GPUs. Are your clock times even making sense when you're using a neutral atom computer with the GPU? This is where qBraid runtime allows for smooth orchestration as well as deep technical proprietary work to make sure that when you are running a NICS algorithm, it actually is going to do something for you. So this is qBook. You may have seen this. There's also a Curera version. There's Curera, qbook.curera.com, as well as a few others out there that you may have seen. You can generate certificates if you are an admin. You can create your own courses, and of course, this is super interactive. You've got videos, you've got code snippets you can write, you can share this with others. You name it, it's there. On top of that, as I mentioned, this is the qBraid lab where many users from academia as well as in enterprise can access anything from the toughest of toughest, NVIDIA cuQuantum, to think about Intel Quantum SDK. How many of you guys know how to install the Intel Quantum SDK? Okay, there you go. So we have one person. It's not trivial. It's pretty difficult. But in qBraid, it's only a touch of a button. So that's kind of a value we offer here that allows for even NVIDIA cuQuantum, your drivers, to all be set up seamlessly. Again, so I'm just going to reiterate myself. So this is where if you have a use case where you're like, man, I just wrote all my code in Qiskit. I want to run it on a broadcast backend. This is where qBraid SDK comes in for transpiling. And then also our runtime. If you are, maybe if you're watching as well, a quantum computing hardware company, we are more than happy to integrate into our runtime service as well, which allows you, maybe you have a team of hardware people, but you don't have a software team that's as competent. You automatically get access to all of the frameworks that people have worked on for many years for this through the SDK, as well as the runtime to coordinate with GPUs using Slurm and other orchestration tools that are commonly used in HPC centers. All right. So that's about it. I could go on if you have more questions, and I have some backup slides about other things. If you want to ask, please do. Thanks.